on the screen. I am. It's great. I'm gonna get started here a few minutes early, give people a chance to get in and getting going. What's up? What's up? What's up, David? What's up, David? Give everybody a second to get in here. As people kind of get going in here, bring those packets and bring up that topic five, and I'll try to get through. I said try to get through as much of this information as I can for topic five. A lot of information, but again, we'll make the best of it. Make the best of it. Like I said, I know I'm a little bit early here, but I want to kind of just give people a couple minutes to get signed in, ready to go. Ready to go. Start it here in about 60 seconds. I don't know you, but I'm loving the loving the fact that our weather now has seems like a almost kind of a broken record. How much our weather goes from being 50 something degrees to now blustering cold. I guess that's the spring. That's the spring, right? Hey Dimitri, what's up? What's up? How's it going? How's it going? It's topic five for those packets out there. And we'll try to get through as much as we can. I'll try to, like I said, get through five here. So, with that being said, let me kind of just get started. I know I'm a few minutes early, but when you look at this, it states at topic five. So when I refer to things as topics, that's what I'm looking at there. Topic five. Okay. I hope everybody's kind of you know, rolling along with me here. So the idea of this is that I want to keep the packet on the left side as we kind of go through here, and then do the work on this side here, so you can kind of see both, so that you can kind of see both ways here. Okay, so that's kind of the way that we're going to work this here. Let's get started. My screen. So when we look at this, we look at that essential question. By the way, am I going to start this from the exact top to the exact bottom? No. We're going to kind of try to roll through this. Um, Ratio. When you look at a ratio, it says what's the answer? What are ratios and rates? Ratio. Ratio compares. So it compares two items. So it compares two items on that. So it asks you, it says, well, what are ratios and rates? A ratio will compare two items here. What am I doing? Thanks. Good group. Yeah, compare. So like in the instance, if I have three circles and I have these are squares which I'm drawing. And if I were to tell you, if I were to say, well, what is the ratio of circles to squares? That is 3 to 4. Three circles to four squares. That's a comparison with that ratio. If you were to write on there, ratio compares. That's probably a good way to say it. This is I don't see math in my folder. What does the first page look like? This is online, David. Yes, this is online. This is within the Google, I believe Google Classroom. On that, I uploaded this to there. You can follow along that way. So ratio compares rates. So, and then when it comes to a rate, so let me get this off of here. You remember talking about a rate. A rate, a lot of times we see rates as in that car gets 25 miles per gallon. This is a rate, 25 miles per gallon. So if you were to say, well, how many miles can you get if you had 3 gallons? Well, 25 miles over 1 gallon. So if I said to you, well, how many miles can you get if there were 3 gallons? Well, 1 times 3 gives you 3. What you do to the bottom, you're going to do to the top. 25 times 3 is 75 miles. Okay. Rate is when it deals with different quantities, like you say, miles per gallon. Well, the miles and gallons don't coalesce. Or if you were to say, if you were to go to a like a grocery store, and you say, well, the bananas are, a buck o, 109. They were $1.09. It's supposed to be a nine. $1.09 per pound. The cost is $1.09 per pound. Well, cost and pound don't actually go together. That's when you're talking about rate. Okay. So if you kind of scroll down here, say, well, we were just talking about this. A relationship in which there are y units of a quantity for every x units of a quantity is going to be a ratio. So a ratio, okay? And I'm not going to write that because of how small that is. So two, the price of a single item. So the price of a single item is called a unit price. A unit price on there helps any. Maybe I'll do this and go one would be ratio, two the unit price, and three, you see a ratio that compares quantities with unlike units of measure, that is our rate. And that explains what I was just talking about there. Unlike units of measure, miles per gallon, cost per pound, they don't normally go together. Let's get to the part where we stopped from yesterday. And that's going to be down here where it says to compare your ratios lesson. So it'd be 5-3 in this instance right there. So when it comes to 5-3, you look here and it says, well, we're just talking about this. So if we're comparing ratios now, we can make a table to show each ratio and then find a value in which one of the terms is the same in both tables. So what this is trying to say? Again, if you remember from what I would always say during our classes here, we say, let talk it out. So we talk it out and we say, like, for number one, the school soccer team buys 3 soccer balls. So 3 soccer balls for every 2 players. That's supposed to be players. The school volleyball team will buy 7 volleyballs for every 5 players. So the question you want to say here is, well, which team will buy more balls per player? If I were to tell you, well, what this is trying to tell you right here, in kind of a roundabout way, is you kind of want to find your least your common denominator for your ratio here. I guess it's a kind of a backwards way of doing it, but it makes sense. So it's saying to you, well, let's get this, the 2 players and the 5 players, to be common. If you start listing multiples of 2, well, 2, 4, 6, 8, and then 10, and then 5 would be 5 and then 10. Your common multiple is going to be 10 in this instance. It's going to be 10. So what you're going to do, let me go back with that. Okay. So 10 players on both sides. Trying to find that same base that you have here of 10 players. So 5 times what is 10? 5 times 2 is 10. What you do to the bottom, you do to the top. 7 times 2 is 14 volleyballs for 10 players. 2 times what is 10? 2 times 5 is 10. Makes what you do to the bottom, you do to that top. 3 times 5 is going to be 15 soccer balls. So when it's asking, it says, well, which team buys more balls per player? It would be the soccer team. So this would be the soccer team. Hello. It would be the soccer team. Okay. Everybody gets that there. Again, you're finding that common base here, or again, your equivalent ratio in that instance. Okay. Again, so then that would work the same thing. That would work the same thing with number two. So you say, well, Jenna walks 12 miles, 12 miles in 5 days. So 12 miles in 5 days. Alex will walk, Alex will walk 7 miles in 3 days. Who walks more miles per day? So who walks more miles per day? Your first step in this instance is you're trying to find common, your common, your common base for the ratio. That's a way to kind of say you're trying to find the same unit when it comes to days here. So you start listing your multiples of 5, which is 5, 10, 15. Go down to the bottom, list your multiples for 3, which are 3, 6, 9, 12, 15. Well, your least common multiple, as you see, is going to be the number 15. So we're going to base our ratios here, our equivalent ratios, off of 15 days. 15 days. And let me get some of the garble out of the way here. And it just works the same, way where you say now, well, 5 days, 5 times what is 15? 5 times 3 is 15, is 36 miles in 15 days. Down at the bottom, 3 times what is 15? 3 times 5 is 15. To the bottom, to the top, 7 times 5 is going to be 35 miles. So when you are looking at your two different comparisons, well, Jenna, the question it's asking is who walks more miles per day? Who walks more miles per day? The answer to that is Jenna. Jenna. Good job, Jenna. Jenna. Okay. Second on that. On here. So I'm going to move to 5-4 now. We talk about representing and graphing ratios. So you can solve some ratio problems by making a table of equivalent ratios. You can make a table of this and then graphing the pairs of values on a coordinate plane. And it shows you your example there when it comes to days of rain and days of sun. And it just shows you, you have your first quadrant graph. That's what this is called, a first quadrant graph on this. And you're basing your rainy days compared with your sunny days and creating a graph based on that. So let's move to now number 1, where it says in gym class, the 6th graders walk 2 laps for every 3 laps they run. So if the students run 12 laps, how many laps will they walk? It says to complete the table and then plot the pairs of values on the coordinate plane. So let's start with the table. Let's start with the table here. So if we start with that table, we find that first ratio that we have is a 3-to-2 ratio. It's a 3-to-2 ratio. If we find that on the run side, on this run side right here, we're adding 3. It's adding that original amount. So it'd be 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. And what you do to the top, in that instance, we're going to double our 2 at the bottom. You're trying to follow that same equivalent way of doing things. So it'd be 2 to 4 to 6 and to 8. And I'm going to erase that here in a second, but 2 to 4, 6, and to 8. Now, in this comparison here, and this is where I'm going to have to extend the screen. Do this here. Go. All right. So there we go. Perfect. What do we know? We know in this instance that our x-axis is going to be the running laps. The running laps is what we know. On our y-axis, just by process of elimination here, is going to be the walking. It's walking right here. All right, so when we create over to 3 and then up to 2, there's our first plotted point. Trying my best to here. If I go over to 6, I go up to 4, I go over to 9, and I go up to 6. I go over to 12, and then I go up to 8. And again, it says if the students run 12 laps, how many laps will they walk? Well, we already figured that out, which is 8. And when we graph it, that is how it's going to look like. That's how it's going to look like. Okay. So when you scroll down to 5, here, 5. So if we scroll down to 5, here, we're talking about rates and then unit rates. So unit rates, not too many undos here. When we talk unit rate, and it tells you right in your quick review, relates a quantity to 1 unit. So 1 unit of another quantity. Keyword, 1 unit of another quantity. So you can use what you know about dividing fractions or reducing our fractions to write a ratio of fractions as a unit rate. Okay. So if we look at this and we say that first one, 78 miles on 3 gallons. 78 miles on 3 gallons. So 78 miles on 3 gallons. What would be the unit rate in this instance? Can we, and obviously we can because we're talking about unit rate here, we can reduce this down. We can divide both the numerator and the denominator by 3, and it makes it kind of easy because there's only one number you can really divide both by, which is 3. If you take 78 and you divide by 3, you're going to get 26 miles, and then 3 divided by 3 is 1. So when we talk about a unit rate, for number 1 will be 26 miles for 1 gallon. 26 miles for 1 gallon. 26 miles for 1 gallon. And like for number 2, when you see 18 laps for 6 minutes, the question is asking you is, well, how many laps per minute? So per minute, you're going to take both the numerator and the denominator, and you're dividing by 3 to get you 6 laps per minute. Okay? 6 laps per minute. And that is not the answer. See, that is not the answer. Why am I doing 3 for? There we go. 6 it is. 6 it is. 3 laps per minute. Good stuff. Good stuff. Do one more here. So 48 good old sandwiches for 16 people. The unit rate in this, you're taking your numerator and your denominator and dividing by the number 16. When you divide both the numerator and the denominator by 16, you're left with 3 sandwiches per person. Must be some hungry people. Must be some very hungry people. So again, unit rates is for, it's based on 1 unit, hence the term unit rate. A few more here, a few more. Let's go down with this. I want to cover this. Let's actually go down to 5. So we talk about 5/8, which is dealing with with the reasoning of this. So we're dealing with units, dealing with converting units, good old converting units. I think we do this a lot since we try to figure out, well, how many feet in a mile, how many inches in a yard, how many ounces in a pound, and so on and so forth. Well, here's the thing. The simplest way to do this, if I look at number 1 and I say, well, 2 miles over some amount of feet. Now, some of you can do this in your head. I'm sure if you know the actual answer to how many feet are in a mile. But the proper way of doing this, you're gonna create your unit of measure. Now, this is where, if you don't remember this, Google is your friend. You can look this up. Just type in how many feet in a mile, how many ounces in a pound, how many quarts in a gallon. I mean, you're doing this at your house. I mean, that's the best way of, you're just like, oh, I totally forgot how much this is. Say Google's your friend on that. It really is. Very simply, we can just cross multiply this. 5280 times 2 is going to be 10,560 feet. And when you multiply this other side, it gives you 1x, which is just otherwise known as full-blown x. So when the question asks you how many feet are in 2 miles, 10,500. 10,560. Okay. And it works the same way with number 2 when it's like, well, if you had 144 inches over a certain amount of yards, you have to say to yourself, well, how many inches are in a yard? How many inches are in a yard? Well, 1 yard is made up of 3 feet. And how many inches are in a foot? Well, there are 12 inches in 1 foot. So 12 times 3 is 36 inches. So 36 inches in 1 yard. So 36 inches in 1 yard. And again, for me, it's when I when I when I myself will cross multiply, I get 144 is going to give you 36x because you don't know what. You don't know what yards are in this instance. Let me get rid of this real quick so I can write further down. So 144 equals 36x. Divide both sides by 36. X is going to equal 4. 4 yards. 4 yards. Okay. I mean, and guys, and the same thing works when you get down to converting metric units. I mean, let's not let's not sit here and let's not sit here and kind of go like, well, not like you can't sit there and look this up. I mean, I'm not stupid. I'm not gonna sit there. You can sit there. I can just show you real quick. If you're working this at your house and you're sitting there going, hey, you can sit there and go into Google for like number one. You can say, well, how many millimeters, mm, that's mm, which is millimeters, in a meter, And when it comes up here, it'll tell you that you have 1,000 millimeters in 1 meter. So the proper way of doing this, and I stress the word proper way of doing this, is to sit there and do the same thing we were just doing, which is taking 3 meters over x millimeters is going to equal, and we just figured it out, that in 1 meter there are 1,000 millimeters. So that's 1,000 millimeters. Again, we would cross multiply, and I believe the term that they use in the book is actually called dimensional analysis, which is kind of an interesting way of calling cross multiplication. It's called dimensional analysis, which is really weird, but that's how things go. So 3 times 1,000 is 3,000, and then obviously 1 times x is just x. So how many millimeters are in 3 meters? Well, that's 3,000. 3,000 millimeters in 3 meters. 3 meters. Okay. And again, I mean, it's the same concept here. When we talk about relating customary and metric units, again, the same thing works. Where it's just you have to know that conversion. You have to know that conversion factor on things. You have to know what, like, how many grams are approximately in an ounce. I mean, you have to be able to sit there and just use that unit, that base rate of measure, to be able to create your you had X ounces in one, what are they saying here? Grams and ounces, which are two totally different things. 100 grams, in X ounces, and guys, it just works. And guys, it just works the same. It works the same way. I mean, you just have to figure out on this to say, well, how many ounces are in a gram? And again, your best friend here, 0.035 ounces. Do you expect you to know this off the top of your head right now? No, obviously not. That's required to look this up at first. 0.035 ounces in 1 gram. So if you say in 1 gram, there are 0.035 ounces. And then when you do your cross multiplication, you'll find that it ends up being 3.5 ounces equals X. 3.5 ounces will equal. Okay. That's all I got. That's pretty much topic 5 in a nutshell. Kind of got through a good amount right there. I hope everybody's staying safe. I hope everybody's Hope everybody's staying safe. Hope everything's going good. If you have any questions, reach out. I said, I hope everything's going good. With that being said, I'll let you guys go here. Again, I hope things are going well. Any questions, reach out. We're always here. We're always here. All right. Have a good day, guys.